folks, I'd like to do a quick video about end behavior to help you with the homework. But before I do a homework problem, I want to discuss some of this notation that we have to use in the homework. Now, this is the leading coefficient test as described in the video. It says if the polynomial degree is even and the leading coefficient is positive, then the left side is going to positive infinity, which is upward, and the right side to positive infinity, which is upward. Now, let's look at a graph. Okay, so function-wise, an example might be f of x is equal to 3x to the fourth. Okay, now what's important here is that value is even, right? And that value is positive. That means it fits this particular situation. Now the graph, if you talk about what's happening there, each side is going up. That graph looks similar to that. I'm not trying to make it perfect. What I want you to see is as x goes to positive infinity, that means to the right, that means the same thing, then what's f of x doing? F of x is the y value. It's going also to positive infinity, which is the same as going upward. So look, as x goes to the right, f of x is going up. And so the part of the graph that I'm talking about is this part right here. That's going to the right and up. Okay, now let's look at the left side. Now the way to say to the left is x is going to negative infinity. If I ever say x is going to negative infinity, that means out this way. Now, as you go out this way, what is the y value doing, which is f of x? Well, it's going up also. So again, a way to think about that is as we go this way, what's my y value doing? It's going upward. So x is going to positive infinity also. So again, to summarize this, as x goes to negative infinity, f of x goes to positive infinity. That means goes to the left, goes upward. As x goes to positive infinity, f of x goes to positive infinity. Again, that means to the right, and this part means upward. Now, on the other hand, if you have something like f of x is equal to negative 3x to the fourth, notice what's important here is this is even, and this is negative. Anytime you have that situation, your end behavior is going to be going downward as you go to the right and downward as you go to the left. Now, the way to write that is on the left side, that means x is going to negative infinity, and f of x is going to negative infinity also. So, if I use my red marker here, as I go to the left, what's my f of x doing? It's going downward. All right? Now let's take a look at the right side. So the right side is saying as x goes to positive infinity, which is the same thing as saying as you go to the right, what is my f of x doing? So as I go to the right, what are my answers doing? They're going downward. So that means f of x goes to negative infinity. Now let's continue this conversation with the other two cases. Remember, there are 4 cases. The first 2 cases involve if the degree is an even number. Notice this time I'm discussing is the degree is odd. And what if the degree is odd and the leading coefficient is positive? If I throw out a very quick example, that might be f of x is equal to 6x to the third. Now, again, what's important is that that's odd and that this is positive. Now, this statement says then the left side is going to negative infinity and the right side is going to positive infinity. Let me show you what that picture looks like. The left side is going to negative infinity, which is down. The right side is going to positive infinity, which is up. Now, if I use notation like Knewton Alta uses, then here's what we have going on. Remember, as x goes to the left, the way to say that is as x goes to negative infinity. Well, what is my y value doing? It's going downward, right? Then f of x is also going to negative infinity. Now, what about as I go to the right? Okay, well, that means this way, the way to say that is x goes to positive infinity. Well, if I go this way, what are my f of x's doing? They're going upward. So that means f of x goes to positive infinity also. And here's one thing I want you to really notice. Anytime it's odd, and this is going to be true for the next situation also, anytime you're dealing with odd, it's opposite directions. So think odd, opposite. But you've got to figure out, is the left going down and the right going up, or the other way around? And you've also got to learn to use this notation. So again, x goes to negative infinity means the left. F of x goes to negative infinity means down. X goes to positive infinity means to the right. F of x goes to positive infinity means upward. Now the last situation, and I'm going to scroll here, is what if the degree is odd? That means your exponent is odd, but your leading coefficient is negative. Now an example of that might be f of x is, let's say, negative 4x to the 5th. Again, what's important here is that's an odd number, and that the leading coefficient, trying to write even, that's not right, is negative. Okay? Now let's look at a graph that meets that condition. And let's get my pen working again. Okay, so here we go. A graph that meets that condition would look the opposite of the one above it. So this and this situation. Okay, and it could be curvy, but here's the important part. As x goes to negative infinity, now what does that mean? That means to the left. As we're looking to the left, what is the graph doing? The graph is going upward. So f of x is going to positive infinity. Well, let's look on the right side. On the right, that's this way. As x goes to positive infinity, what are my y values doing? They're going down, which means f of x goes to negative infinity. Again, they're opposite. The left is going up, the right is going down. So what could be throwing you off, if you've just watched the regular video, is this new notation. Easily it throws everyone off. Now, let's see if we can't do a homework problem or two to clear up any confusion. Okay, so now I've got a homework problem pulled up from homework number 19, which is determine end behavior. So let's take a look at this homework problem. We've got describe the end behavior of the function f of x equals 3x to the 4th plus 19. Now here are the important details. Remember, there's two things you're looking for. You are looking for the degree of the polynomial. That is the highest exponent. So this is a degree 4. Now what matters is that's even. Okay? The next thing that you're looking at is the leading coefficient. The leading coefficient is the 3 right here, and that value is positive. So you have a positive leading coefficient with an even degree. That's the first case that we took a look at. Visually, let me remind you, that's this situation right here. So we have an even degree with a positive leading coefficient. Notice both sides are going upward. Another way to write that is as x goes to negative infinity, that's to the left, f of x goes to positive infinity. I should have wrote in, there it is. As x goes to negative infinity, f of x goes to positive infinity. As x goes to positive infinity, f of x goes to positive infinity. Sometimes I just realize I write these vertical and sometimes horizontal. So if we're looking at this situation, these two things go together. As x goes to negative infinity, f of x goes to positive infinity, and then these two situations. As x goes to positive infinity, right, f of x goes to positive infinity. In other words, the f of x's both go to positive infinity. That was probably overkill. All right, so back to our situation here. That's what we have. Now let's scroll down and look at our options. Okay. We don't have options. We just type in our answer. So as x goes to positive infinity, f of x goes to, and I need to type in positive infinity. Okay. So how are we going to do that? Well, in my situation, I need to scroll down and I can just click on positive infinity. And then as x goes to negative infinity, this means to the left. So this means to the right. Our y values go to plus infinity. This means to the left. And our y values also go to plus infinity. And again, my keyboard keeps popping up. I'm sorry for the distraction. There we go. Okay. And then, of course, I check my results. So I'm going to submit my answer, and hopefully, look, we got green. Now, this is probably not the question that you've been asking about, but that is the most basic kind of question that they cover. So let's find another problem. You want to? Now, here's an interesting question, okay? Which factor could be part of the function so that f of x is increasing as x approaches negative infinity and positive infinity? Now, increasing means going up. Decreasing means going down, okay? I'm not a real big fan of saying that because our definition of increasing means it's rising from left to right, but they just mean f of x is going up, okay? Now, f of x is going up as x approaches negative infinity and positive infinity. That means to the left and the right, okay? So we're talking about an even degree. If they're pointing the same direction, this is an even degree, right? Okay. What else? You have a positive leading coefficient. So, for example, 3x to the fourth. That's the example we used earlier. Again, because both sides are going up, that's the f of x is increasing part, as x goes to both sides. X goes to negative infinity, means to the left. X goes to positive infinity, means to the right. So we need an even degree positive leading coefficient. Now what's sitting there right now is x to the third, right? X times x times x is x to the third. Well, that was an odd degree. To make it even, then we would need to multiply by another x, and notice this is a positive leading coefficient. So this one will work. Notice this says select all that apply. So this might not be the only correct answer. Let's scroll down. Now, if I multiply by this 3x by all of this, again, a 3x times x times x times x is going to give me a 3x to the fourth. Once again, that's an even degree with a positive leading coefficient. I'm going to check that one. I'm not going to check this one, because if I multiply all of this by a negative 5x, that's going to give me a negative 5x to the fourth. That's a no-go. That means both sides are going down to negative infinity. We can't do that. If I multiply this by x plus 3, that would give me an even degree and a positive leading coefficient, because this 1x times this 1x times this 1x times this 1x would be a 1x to the fourth. Again, positive leading coefficient, even degree. And then the last case, what do we think? No. Why? Because you take 2x squared times x times x times x. That would be 2x to the fifth. Now, whenever you have an odd degree, that means they point in opposite directions, right? And they're supposed to both point upward, so we don't check that one. So these three would give you an x to the fourth with a positive leading coefficient. And I would like to check that result to see if it's right. Yay, we did it right. Hopefully this is making a little bit more sense. I know this homework is confusing, so we're doing the best we can. Let's find another example. Now here's a third question. This reads very similar to the last one, and you would think that the last one would be enough to show you how to do these, but this has this extra point of confusion, so I'm doing another one to make things clear, I hope anyway. This says which factor could be a part of the function so that the graph of the function is decreasing, that's important, as x approaches positive infinity. Now let's look at a picture so we know what's going on. Again, as x approaches positive infinity, that means to the right. If I could underline it, I would. I can't. As x approaches positive infinity, means to the right. And then it says the function is decreasing. Okay, again, let's draw a picture. So just a quick sketch of a graph. Now, as x goes to positive infinity, means this way. Okay, and it says our function is decreasing, so it's going down. That's the end behavior we're looking at. Notice as x goes to the left, they didn't ask us a thing. Here's the deal, though. There's two situations this happens. If, you have the situation where they both go down, like it goes down on the left and it goes down on the right. Well, that would be an even degree with a negative leading coefficient. Okay? Even degree, negative leading coefficient. But you know what? We have another situation. What if we had an odd degree, and that's also a negative leading coefficient? So an even degree negative leading coefficient might look like this. On the other hand, let's do this in red, An odd degree negative leading coefficient would look like that. But since we don't care what happens on the left side of the graph, we only care what happens on the right, which is the stipulation they gave us, then both of these situations check the box. Now, notice it doesn't matter what the degree is. What do we need? We need a negative leading coefficient. So if we know we have a negative leading coefficient, we have found the right result. Now we're back on our choices. Notice what we have right now. It is an odd degree, but remember we said it doesn't matter. We just need to multiply by something to give us a negative leading coefficient. And y'all, if you multiply this by -4, that'd be -4 times x times x times x, which would be -4x to the third. I need to check that box because that would be a negative leading coefficient. If we multiply this whole thing by 1/2 x, that's not going to be a negative leading coefficient because 1/2 times x times x times x would give you a positive 1/2 times x to the fourth. That's not going to work. All right, let's keep scrolling. I take this up here and multiply it by -2x plus 11. And y'all know that negative is going to make all of that stuff negative. So that's going to be a negative leading coefficient. But look, the next one won't. 4x plus 7 times all of this will give you 4x times x times x times x, which would be 4x to the fourth. But we need it to be negative something to x to whatever. We don't care. Now, if I multiply by all this, that's going to give me a negative leading coefficient, right? Because -2/3 x squared plus 11 is going to be -2/3 times x squared times x times x times x, which would be -2/3 x to the fifth. That would be a negative leading coefficient. So let's submit. Look, we got it right. Yay, we're doing awesome. What do you think? You think that helps? If it's not enough, send me a message. My time is running out, so I'd have to create a new video. So hopefully that helps. But again, let me know if you need more examples or send me your particular example. I'll take a look at that as well. I hope you all have a wonderful day. Bye.